So we can use the laws of logs to either expand or contract an expression into something else based on our needs. For the needs for this example, we need to expand these expressions. So with A, we need to look at the operations between x, y, and z. We're going to have log base 5 no matter what, because that is not going to change. We'll have log base 5 of x. Now the operation between x and y is multiplying, so in order to split that into multiple logs, that would be 2 logs that are added. So they're plus log base 5 of y. The operation next is dividing, which means to split that into another log, we'd subtract log base 5 of z. B is actually going to require us to use a law of exponents. First, we have the cube root of x. We need to express that as an exponent. A cube root becomes an exponent of 1/3. Now that we have the exponent, that exponent can drop out front, and we have 1/3 log base 7 of x. C will have log base 6 of 1 to start it off with. The operation is dividing, so to split that into logs, we'll subtract log base 6 of x squared. This next step on C is for enhanced understanding. It's not necessary, but log base 6 of 1 is actually 0. Go back and do what we did a couple of sections ago and actually evaluate that log. You get 0 minus log base 6 of x squared, or just negative log base 6 of x squared. We could actually take that one step further and bring that 2 exponent down and have negative 2 log base 6 of x. D I'll do on this side just for space. We had the log, common log, of x cubed over y root z. This is similar to A, but it's got one key difference that I'll get to in a second. We can start off with log of x cubed. We would then subtract log of y, and this is where the difference changes between A and D. In D, we had 2 items multiplied on top, so it was log x plus log y. Because the y and the z are on the bottom, the overall operation is dividing, so we would again subtract log of root z. Can do a little bit more with this. 3 exponent on the x can come down. The square root on the z, we can express that as an exponent of 1/2. And last thing is that exponent of 1/2 on the z can actually come down as well. And there we go.